average rate of change versus instantaneous rate of change. Let's talk about Amy. Amy takes a trip from Chicago to Milwaukee. The graph shows Amy's distance in miles from Chicago. So this is her distance from Chicago, and that is her time in hours. So obviously every one of these then would be 15 minutes. So let's see what it's asking you to do. And let me say that you can have a calculator out. I'm not going to show the calculator because you're just using it for simple calculation, so I think you know what buttons to push. But you will need a calculator just to explore this first one because the numbers aren't all beautiful. At some point on her journey, Amy stopped at McDonald's. How long was she there? So you've got to be able to interpret a distance versus time graph. So her distance obviously is increasing. She's getting further and further away from Chicago. Now, where would she be stopped? Well, hopefully you can see you're looking for where her distance isn't changing. So where her distance is constant would be where she has stopped. And how long was she there? Well, she was there 15 minutes to get her Big Mac. So she was there 15 minutes. Perfect. What was her average speed for the entire trip? What was her average speed? If I ask you your average speed, what would you do? Well, okay, the whole trip was how long? 2 hours and 15 minutes, but obviously if we were doing that in time, it'd be 2.2 hours. And they gave you this point right up here. So we would take her total, the distance she traveled, or her change in distance, over the change in time. So distance over time, that would be her average speed for the entire trip. Now, as silly as this sounds, I want to show it like this. So I'm taking basically this point at 0, 0, this point at 2.2585, and I'm finding the slope between those. Now, obviously, I know that the minus 0 is silly, but I'm really using that for the next one for you to see that you're doing the same thing. And if you type that in the calculator, 85, her total miles, divided by 2.25, you would get 37.778. Now, in calculus, you have to know that you always go to 3 decimal places. Unless the question tells you to round to the nearest whole, which sometimes it does, you always go to 3 decimal places. Always. And if units are introduced in the question, then you have to put units on your answer. So if this is a speed, of course, it's miles an hour, so this would be miles per hour. So I've got to make sure I put that on my answers. But what if I didn't want to know her average speed for the whole trip? What was her average speed from the point where she stopped for McDonald's to the end of the trip? Now, where did she stop? Read carefully. Where did she stop? She stopped right here. And so what I'm really finding in this example is the line, the slope of that green line. So I'm going to go through, again, my points were 140 and then 2.2585. And I'm finding the average speed, so I'm taking the slope of that green line, so I'm going to do the same thing, but now I don't have 0, I have 85 minus 40 over 2.25 minus 1, and I would get, when you type that in, 36 miles per hour was her average speed. So you're just finding the slope of some secant lines, correct? So if I wanted to, I'm going to kind of shoot on up here. So really, the average rate of change, you're finding the average rate of change of position. That's what you're doing in this question. That's just the slope of a secant line. Now let's compare that to what letter D is asking us. Letter D is asking us, what is our instantaneous velocity at 45 minutes? So what that's saying is at 45 minutes, which is right here, what is her instantaneous velocity? What would you be doing there? What would you need to be doing? You would be needing to find the slope at that point. And so that is linear, so you would have to calculate that. And the slope of that point is going to be the slope between these two definite points. And you could find that. So it looks like that you're finding the slope of a secant line, but you can almost do it like this. You have a change of, what is that, 10, 20, 30, right? So that's 30 miles and then half an hour. So wouldn't that be 60 miles per hour? Hope you're okay with my figuring that slope. I'm trying to find the slope of that line. At 2 hours, let me erase some of this so my graph isn't so cluttered with things. At 2 hours, what would I be looking for? At 2 hours, I would be looking for the slope at that of this line. So I could try to figure that one out as well. This one is a little bit, I don't know if I can count quite as well on this one, but 10, 20, 30, 35, wait, yeah, 10, 20, my eyes can't see, 10, 20, 30, 45. So on this one you had a 45, and then what was the change of time? You're going from 1.25 to 2.25, correct? So 1.25 minus 2.25, well, that's an easy one. And I would get 45. And then finally, at 70 minutes, well, where is 70 minutes? Now be careful, 70 minutes. 70 minutes would be right after an hour. So along in here, well, what is her instantaneous velocity there? Well, she's not moving. So that would be 0 miles per hour. So notice the instantaneous velocity, when I have a distance versus time graph, is really the slope of the tangent line at that point. So like this last one really shows it the best, is right here. What is the slope of the line that I'm on is, of course, 0. So the instantaneous rate of change is the slope of a tangent line. So as we move on, I kind of abbreviate these because I didn't want to have to tap out average rate of change and instantaneous rate of change. So when I say AROC versus IROC, that's what I'm talking about. So AROC, average rate of change, and then IROC, instantaneous rate of change. So for example 2, you're not going to be finding it all, but you just have to understand what the question is asking and see. It's a comparison game, okay? So you're not going to be finding any numbers, and that point A should be on the graph, but a little off there, but that's okay. So what does this say? The AROC, the average rate of change between A and B. So I like to draw. So that would be the slope. Very hard to draw accurately with this pen that I have. So the average rate of change between A and B is what the average rate of change between B and C. Well, that should be an easy one. Because if you found the slope of the blue line, you would have a positive number. This would be a positive. And the slope of of BC is a negative, so a positive is always greater than a negative. Now, I always get this question, well, what if my positive number is like kind of flat and my negative number is really steep? You guys, this isn't physics, this is math, okay? Is a positive number, the slope is positive for this one and negative for this one. A positive is always greater than a negative. I am not talking about magnitude. I'm talking about their slopes. So it would be simply that. Now let's look at the next one. See if you can figure out what you're comparing in the next one. The IROC at A, the instantaneous rate of change, so that is the tangent line, the slope of the tangent line, is what to the IROC, the instantaneous rate of change at B. So those two tangent lines, the slope of the tangent line at A and the slope of the tangent line at B, well, they're both positive, but which one would be a bigger number? Well, of course, the steeper one, so I also get greater than on that one. So last one, the average rate of change, I'll leave the instantaneous rate of change there of A, that's actually this one is actually the blue line. And then the average rate of change between A and B, that was this one again. So once again, which one is steeper? Those are both positive, but the IROC, the tangent line, is steeper, so I would get greater than. Do you notice something about the average rate of change and the instantaneous rate of change? Do you notice for average rate of change, I had to give you 2 points? Well, that should make sense, because if you're finding the slope of between 2 points, you got to have 2 points. The slope of a secant line is the slope when you have 2 points, whereas the instantaneous rate of change is the slope at 1 point, the slope of the function at 1 point, so you're only needing 1. Now let's try to do this next example without a calculator. So let's pretend that you do not have a calculator for this next one. It says find the average rate of change of f of x from -1 to 2. So what is that really saying that would be in an Algebra 1 class? Oh, average rate of change, find the slope of a line that goes from points -1 comma something to 2 comma something. Now I've got to find those points. So that's actually how I start. I find f of -1 and I find f of 2. I'm going to do that in my head. I hope you're okay with that. So -1, that would be 1 minus 1 minus 2. So that would be -2. If I did 2, that would be 4 plus 2 minus 2. So that would be 4. So friends, do you see all I'm doing is I'm finding, I've got 2 points, -1, -2, and 2, 4. Now find the slope between those, and I will tell you this, I know that you are smart enough that you could get that slope in your head and just write an answer. Anytime you are finding slope, I am telling you, write it out. Write out that difference quotient, because many times you're in the free response, it's worth a point. So I'm just telling you now, anytime you're finding slope, write it out. Even if it's -0, literally put -0 and go from there. Now from there, if you wrote the answer, fine. So 6/3, so the average rate of change of f of x from -1 to 2 is 2. The instantaneous rate of change at -1. Well, what is that really asking? It's asking for the slope of the tangent line at -1. Well, thank goodness that I know how to find the derivative quickly. I can say that's 2x plus 1, and then I just have to pop in -1, and I would get an answer of -1. So I have that the instantaneous rate of change at -1 is -1. Now, what does that tell you about f of x at -1? If you know the derivative is negative, what do you know? If you know the derivative is negative, you know that F is decreasing. F would be decreasing at x equals -1 because the derivative is negative. Okay, so we see how we kind of pull it together. All right, let's look at this last one. This last one is a formula that I'm sure that you're, especially if you're in physics, although you won't like the fact that we in calculus use 32 for gravity, or -32, because we're usually in feet per second, versus you in physics, I know, do the meters per second squared. So you're going to have to get used to that. I know that kind of wigs you out. But this formula, -16t squared plus v naught t plus s naught, gives the distance above the ground of an object that's going through the air, where v naught is the initial velocity and s naught is the initial height. So we're talking about Adam diving off of a bridge, 48 feet. Gosh, that's a tall bridge. 48 feet above the water with an initial velocity of 32 feet per second. Write an equation that gives his position at any time. Really his position, in other words, his distance above the ground. Now later in our course, we will actually derive this formula, but we have to know integration first. So we'll just have to go with it for now. So what is my position equation? S of t, -16t squared. It's negative because that's the gravity part. That's the acceleration that is due to gravity that is pulling us down. Now v naught, it said that the initial velocity was 32 feet per second. So I have 32 t plus 48. And now what is it asking me? It's asking me for Adam's average velocity on 1 to 2. And so here's what I'm going to do. I'm going to find his position at 1 and his position at 2. Need a little more space. These are tiny. So what is S of 1? Now let's just pretend that I said you couldn't use a calculator. I think you can figure out these numbers. They're not too bad. So S of 1 would be -16 plus 32 plus 48. So that would be 48 plus 32, which is 64. And then if I plugged in 2 squared is 4. 4 times -16 is -64. Ooh, that's nice. Plus 64 plus 48. So that one's going to be 48. So now I'm going to do, I just have to subtract these. Again, it doesn't matter which order. So if I go 64 minus 48, I have to remember to go in the same order, so that would be 1 minus 2. And 64 minus 48 is 16, but on the bottom I have a -1, so I would get -16 feet per second. Now why is it negative? Because he's going down. His velocity, there's a direction associated with them. And I want to be very clear. When this says dives, when it said the initial velocity is 32, it really means he's kind of jumping up, and then, so his initial velocity is going up, and then he's going down, and that's why that is positive. Okay, when will Adam hit the water? Well, what would that mean? Well, if S is the distance above the ground, then he'd hit the water when S of t is equal to 0. So I said no calculator. So if I set this equal to 0, I'm going to divide by -16 to make my life simpler. That would be t squared, so I'm just factoring this. I would have t squared minus 2t minus 3. I'm going to set that equal to 0. I'm going to factor this piece, which would be t minus 3 and t plus 1. And of course, the negative doesn't make sense, so he would hit the water after 3 seconds. What is Adam's velocity at impact? So isn't that asking for his instantaneous velocity at 3? So his instantaneous velocity, I could find velocity is the derivative of position. So if I have a position equation and want a velocity equation, I am going to take the derivative. So I'm just going to do power rule on this one. Negative 32t plus 32. And since it's asking me about impact, I'm going to find v of 3. So I would have negative 32 times 3 plus 32, so that's really negative 32 times 2, which would be negative 64 feet per second. And that's what you will be doing this evening. I will tell you that the one on your homework, you probably will need to use a calculator. So let me say this, because it's kind of nice to know this as well. The numbers, I wanted to do it without a calculator to show you that you could. And if it's on a non-calculator part, then you're going to have to solve those things with your algebra skills. But I'm going to go back to this one and tell you something about a calculator portion of the test. If, let's say this was a calculator part and I wanted to use my calculator. Right here when it says, when will Adam hit the ground? And I said that's where S of t is equal to 0. What could you do on your calculator to get that? Well, remember, if you have an equation and what it equals, you would put this in y1 and this in y2 and see where they hit. So you would find that. The good news about a calculator portion is all you have to write is this. You have to tell the equation that the calculator is solving. So if you have written S of t equals 0, if this were a calculator part, that's actually all of the work that would have to be on your paper. S of t equals 0 at t equals 3. If you've named the equation, you don't have to rewrite the equation. And so get in the habit of writing and using the name for your work. So if you're using a calculator, you have to write down, and you do an intersect, you have to write down the equation the calculator is solving, but that's all you have to write down. S of t equals 0 at t equals 3. Boom, done. All right, good luck to you.